Okay, we're live. Sweet. Hey,
Okay.
so how was your? What do you think? How do you think this week was?
It was pretty good. Pretty easy.
Yeah.
It looks like we have to discuss part two and do that
Yeah, we do.
in the
Right?
prep assignment. Yeah.
Oh, we do. Dang it. All right. All right. I mean, it should be easy. I looked at it and everything. Um. Okay. So it says to choose five numbers. Um. Which one do you want to do?
We can do
Should we just do like the um just like 5, 10, 15, 20, 25?
perfect. We'll just do all the ones on the right.
Okay, awesome. Let's do it. Get my calculator. Oh man, I'm so tired.
What time is it there?
It's like 12:40 in the afternoon. I'm
Oh,
so, I'm so not used to the time yet.
yeah, I bet.
Okay, so it is 34400 plus.
So I got 41,366.
Oh wow, that was quick. Um, 3,745,000. So you got what?
I got 41,366.
Wait, I did something wrong. What did I do wrong? Wait a minute. Wait. Okay, so sorry. Uh, 37, 45,000. You can divide that by 5. I got 40,600.
Oh, I did 45,200 too. I did that one. I did all of the ones in the right column.
Oh, you did that one as well.
Whoops. 203,000 divided.
I think it says only 5
Okay,
numbers.
so I got 40,600.
Okay, sweet. Okay, let's put that down. 40,600. And that's number 5, 10, 15, 20, 25. Okay, this graph illustrates sampling distribution of sample mean. There are 142,500 drawn 5 at a time. This graph represents. Make a mark on the horizontal axis to indicate the value of the sample mean from part A. It would be it'd be on the lower left. It'd be right at like the edge of the left. Okay. Does your sample mean appear to be unusual? Yes. Because it'd be skewed left.
Yeah, because it's not in the middle. It's not even
No,
close to being in the middle.
no. Why do you think that is?
Hmm. Probably because, uh,
Oh, I think I know why.
because the numbers we chose weren't really like.
Representative of the whole sample.
Plus, we only picked 5 random ones, so.
Yeah, you're right. The number we chose definitely didn't represent the whole sample because like the sample goes up to like 59,000, 52,000, like 50,000,
And
52,000,
the highest we
57,000.
went was 45,000.
Yeah,
45,500.
yep. So that's why it wasn't representative of the whole of the all the numbers. Um, Compare your mean from question 8A to the mean obtained by at least three others individuals. Um, but we don't have any other people to compare it to. So, but I'm guessing it's the same, unless they choose like super like spread out numbers. If they
Yeah,
choose like 30, 35, 40, 45, yeah,
then it'd be better, but
yeah. Okay, the graduate management admissions test. My friend just took that to GMAT.
oh yeah.
Yeah. And the Masters of Business Administration, the scores in the GMAT are normally distributed with a mean of 529, standard deviation of 113. Simple random sample of 10 students taking GMAT. What's the shifted distribution of the sample mean for all samples? Um, mhm, let's see. If the mean is 529, um, standard deviation is 113. Um, if it's simple random sample SRS, then it'd be normal.
Yeah.
Because they're not taking any scores from like the extremes, like people who gets really high grades or people who gets really low grade. Um, and so I would think it's normal.
Yeah, I agree.
Okay. Mm, How do you know distribution of the sample mean has to shape? Well, I think just because all the scores we're getting it from it's simple random, so the scores are random, so all the test scores are normally distributed.
Yeah, it's normally distributed.
Mm.
What is the mean of the sampling distribution? Mean scores for all mean of the sampling distribution, sampling parent population. Is it mean 529?
Yeah, it's right
Is it?
there. Yeah. So
Yeah.
the scores from the GMAT are normally distributed with a mean of 529. Um, so because the sample mean is equals to the population mean.
Yeah.
Um,
And then the standard deviation is
to calculate it.
113.
So what's that? What's that equation again that calculates? I have it. I have it saved. Wait. Um,
It's like,
it's like um.
I would just do it in Excel.
It's for the samples, right? For the
Yeah.
samples mean for all such samples. So it'd be the given
So,
standard deviation divided by the root of 10
yes.
because it's like the theta over root n.
Yeah.
So it would
It's the
be
square root of the variance.
yeah. So it'd be 35.73373755599026
Perfect.
So it's 35.734. Okay. Awesome. We're good? See?
Good.
See, bueno. Let's move on to this. Okay.
Let's see.
Okay. You ready?
Ready.
Okay. So, number one and number two are true. Number three. Mhm. Okay, sorry. So it says when you're taking a sample size of n equals 5, the shape distribution of the distribution of means histogram, but apparent distribution is right skewed. Um, I'm reading. So if the sample size is small and it's right skewed, it is skewed. But if the sample size is large and it's right skewed, then it's normal. Um,
Oh,
so
so it's skewed right?
yeah, it's skewed right because the sample size is really small. 5 is like super small. Um,
Okay.
4.
So it's one if it's 100 then it's normal.
Yeah, I'm pretty. 100's a lot, so yeah, I'm pretty sure it's normal. Okay. Um,
And
and
then if
then
it's normal, it's obviously normal.
yeah, obviously, yep. And this one, it's normal, so it's normal regardless of the number of size, the sample size.
Yeah.
Um, so the next one says, well, when the distribution of means be normally distributed?
Um,
Well, A and B for sure, because they're both normally distributed to begin with, regardless of sample size.
isn't it supposed to say data is drawn?
Data. Yeah, yeah. Well, someone's grammar is very incorrect. You're right. It's supposed to say that. But A and B are definitely true, regardless.
Data are drawn.
Because they're
C
both
C is not
no, because the
because it's
sample size is
small
small. Yeah.
and
D
right skewed.
D is because sample size is large.
Right skewed. Yeah. Then A normal. Yeah.
Okay, so it says the following gives the best explanation of central limit theorem. The parent population from which data are drawn is normally distributed. Then the sample mean will follow a normal distribution. For bell-shaped data, approximately 60% will be within 1 standard deviation. It's not B because that's not the central limit theorem. Let's talking about the 68, 97, 99.7 rule.
Yeah.
Um, it's not A. The parent population in which data are drawn is normally distributed, sample mean will follow a normal distribution.
D is correct. Like that's true.
If the sample size is large, the shape of the distribution sample means will be approximately normal. If the sample size that's true. I think that's it. You're right. I think that's it. D. 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 Information. Let X be a random variable with a population mean of 10. A population standard deviation of 6. Suppose a sample size of 36 is drawn from this population. What is the mean of sample distribute? What is the mean of the distribution of sample means? Well, sample means is the same as population means, so it
Well,
would
it's
be
10.
10. Yep. Here. Um. What is the standard deviation of the distribution of sample means? Um. What is that calculation again? Let me calculate it. So it's 1. Exactly 1 actually. Because it's 6 divided by square root of 36. Which obviously is 1 because that's 6 over 6. So it's 1. So
We have to round to
3. I think 3. It's always 3 for some reason. Yeah. So it's just we'll just put like 1.000.
okay.
Okay. Regardless of the distribution of the population, if the sample size is large, so that's greater than 30, what would be the shape? It'd be normal.
Because it's
Regardless,
large.
exactly. Regardless, that's the central limit theorem. If the sample size is large, then it is normal. So it is
Which is
normal.
12. Also. Because the central limit theorem.
Yep.
Yeah.
All right. Submit.
What?
You think you're
Yeah.
ready? Okay.
Mm-hmm. Boom.
What we get?
Hey.
Yeah, baby, we're good at this. It's pretty easy though, I feel like.
It's so easy because I learned all of this stuff in high school.
Yeah. And it's like the same, basically same as like all the stats class I've ever taken. So,
Yeah.
alrighty.
It's easy.
Okay, wait, let me stop
I'll be
broadcast.